For almost 100 years, one of the biggest showdowns in science has been Albert Einstein versus the bizarre world of quantum mechanics. And at the heart of it all was this idea so weird that Einstein himself called it spooky action at a distance. Today, we're going to look at a brand new take on this problem that suggests something wild. What if everyone was right all along? So this quote, it really gets to the heart of what bugged Einstein so much. Just imagine you have a pair of gloves. You put one in a box, the other in another box, and you mail one of those boxes to the other side of the galaxy. The second you open your box and see, say, a left-handed glove, you instantly, and I mean instantly, know the other one is a right-handed glove. Quantum mechanics says particles can do a version of this. And for Einstein, that was just impossible. It seemed to break the ultimate speed limit of the universe, the speed of light. I mean, how could that information get from one particle to the other instantaneously? And right there, you have the ultimate clash of titans. On one side, you've got Einstein's powerful gut feeling that reality has to be local. What happens right here shouldn't instantly mess with something way over there. But then, on the other side, you have mountains of undeniable experimental data. Physicists like Bohr, Bell, and Aspect ran the tests, and the results are crystal clear. The math of quantum mechanics just works. It's perfect. It predicts these spooky connections with literally flawless accuracy. This really feels like a dead end, doesn't it? A paradox with no way out. But what if we've been looking at it all wrong? A really fascinating new perspective asks a totally radical question. What if this isn't a game where someone has to win and someone has to lose? What if they were all right? Okay, to get our heads around this, we've got to shift our thinking a little bit. The usual explanation for all this spooky stuff is a concept called non-locality. This idea that things can affect each other instantly across vast distances. But this new perspective says, nope, that's not it. The real answer is something way more fundamental, something much deeper. And it all comes down to this one key idea, non-separability. This concept suggests that two entangled particles, they aren't two separate things sending secret messages to each other. Instead, they are, and they always have been, a single unified system. Think of it less like two different gloves and more like the two ends of the same glove. When you measure one end, you're not sending a signal to the other. You're just revealing a property of the whole thing. They were never really separate to begin with. So how can that even be possible? How can things be separate in the world we see, but also unified at some deeper level? Well, this brings us to the absolute core of this new model, the idea that reality actually operates on two different levels. This two-level structure is the crucial bit, so let's look at level 1 first. This is the true fundamental reality. It's a single, unified nature, where ideas like here and there don't really mean anything. It's one whole system. This is the kind of reality Einstein's intuition was pointing to. And then you have level 2. That's our world, the reality we experience, the one we measure. It's full of separate objects and distinctions. And this is the level that quantum mechanics describes perfectly. The whole paradox only exists because we've been trying to apply the rules of one level to the other. Here's a great way to think about it. Imagine level 1 is a real 3D object, like a spinning cube. And level 2 is the 2D shadow that cube casts on a wall. Quantum mechanics is the perfect mathematical description of that shadow. It is 100% correct about everything the shadow does. But the shadow isn't the cube. All the spookiness we see is just a weird feature of the projection, not of the actual object itself. And this is where the story gets really incredible. I mean, where would you even look for evidence of a deeper, unified reality? Well, you're not going to believe this. The clues might have been hiding in plain sight this whole time, right inside Einstein's own famous equations for general relativity. It turns out that the part of his equation that describes the fabric of spacetime is way more flexible than even he thought. His math actually allows for huge, large-scale waves to ripple through the cosmos, phenomena that don't need to be explained by tiny particles pushing and pulling things. This hints that maybe reality, at its core, is a more holistic, unified, geometric thing. And this is where the idea gets really powerful, because if you look at the universe through this two-level lens, some of the biggest mysteries in cosmology might just dissolve. Take dark matter. The standard view is that it's some mysterious particle we haven't found yet, but in this new interpretation, maybe it's just the effect of those large-scale geometric waves. And dark energy? We might not even need it. It could just be a mistake we made by trying to describe a flexible level 1 reality with our rigid level 2 mathematics. Okay, let's put all the pieces together. What we're left with is this beautifully elegant solution. It completely reframes the whole debate by putting quantum mechanics in its proper place as an incredibly successful theory, but one that's ultimately describing an incomplete picture of reality. So what's the bottom line? Well, it means Einstein was right. At the true, fundamental level 1 of reality, there is no spooky separation. But it also means that Bohr, Bell, and Aspect were right. Their quantum statistics perfectly describe what we see and measure in our level 2 reality. Quantum mechanics is the correct theory for the world of distinctions we live in. But here's the kicker. Nature itself, at its deepest level, doesn't make those distinctions. We do, every single time we take a measurement. And that leaves us with a truly profound, kind of mind-bending final thought. If this is right, it means that everything we see and experience, every particle, every star, every interaction, might just be a projection, a shadow cast on the wall of our perception. And it really makes you wonder, what does the real, unified reality actually look like?